Tonight, step outside and look up. There it is, our familiar companion, the moon, hanging like a pale lantern in the darkness. But imagine, just for a moment, that what you're seeing isn't the cold, gray world we know. Instead, picture something extraordinary, a moon painted in brilliant blues and greens, with wisps of white clouds drifting across its surface like cotton pulled thin by invisible hands. Can you see it? Oceans that catch and scatter Earth's sunlight, creating a shimmer that dances across the lunar face. Mountain ranges draped in what might be forests, their canopies swaying in winds we can't hear but somehow sense. And there are those lights, tiny pinpricks of illumination scattered across the dark side, like cities breathing with life 39 times farther away than any earthly metropolis. This isn't science fiction. This is a thought experiment that challenges everything we think we know about our place in the cosmos. For over 4 billion years, humans have gazed upward at a silent, airless companion. We've written poems about its mystery, planned our harvests by its phases, and dreamed of walking on its dusty surface. But what if all along, we weren't alone? What if, instead of being Earth's solitary satellite, the moon was Earth's neighbor, a living, breathing world with its own story to tell? The implications would ripple through every aspect of human existence. Our mythology would be different. Our science would have developed along entirely new paths. The very concept of life in the universe would be fundamentally altered, because we wouldn't have had to look to distant stars to find our first evidence of extraterrestrial existence. We would have seen it every clear night, hanging right above our heads. But before we step into this alternate reality, we need to ask, what would it take for the moon to even hold onto an atmosphere? The moon's current silence isn't an accident. It's the result of cosmic mathematics written in the language of gravity and time. To understand our hypothetical living moon, we first need to understand why our real moon is so impossibly quiet. Imagine the moon trying to hold on to an atmosphere like a person trying to carry water in cupped hands. Earth can do it easily because our planet has strong enough gravity, about 6 times stronger than the moon's, to keep gases from simply floating away into space. But the moon? Its gravitational embrace is too gentle, too weak to prevent even the heaviest atmospheric gases from eventually escaping into the vast emptiness around it. For our alternate moon to breathe, it would need to be fundamentally different. Picture it growing larger in our mental telescope, perhaps twice its current size, with a mass dense enough to create the gravitational pull necessary to trap and hold an atmosphere. The physics are unforgiving. Gases move faster when they're hot. And if they move faster than something called escape velocity, about 1.5 miles per second on our current moon, they simply drift away, molecule by molecule, until nothing remains but vacuum. But there's more to this cosmic recipe than just size. Our reimagined moon would need protection, a magnetic field like Earth's that could deflect the solar wind, those streams of charged particles constantly flowing from our sun. Without this invisible shield, even the thickest atmosphere would be gradually stripped away, like paint being sandblasted from a wall over geological time. NASA discoveries have shown us that Mars once had both an atmosphere and flowing water, but lost them partly because its magnetic field failed. On our living moon, we'd need that protection to remain intact, creating an invisible cocoon that would allow weather systems to develop, seasons to change, and most importantly, life to take hold and flourish. The moon would need to be massive enough to hold onto water vapor, which would condense into clouds, fall as rain, and gather in the ancient impact basins that would become seas. These lunar oceans would be strange places, with gravity only 1/6 that of Earth's. Raindrops would fall slowly, almost floating downward, and waves would move in dreamlike slow motion across waters that might stretch for hundreds of miles. So, if the moon could finally hold an atmosphere, what would it look like from Earth? Every clear night would become a revelation. Instead of the familiar silver coin we've known throughout human history, our sky would hold something magnificent, a world you could actually watch change from hour to hour, day to day. Picture storm systems sweeping across the lunar surface, massive spirals of cloud that would be visible to the naked eye, swirling slowly across familiar crater patterns now softened by atmosphere and weather. The Mare Tranquillitatis, the Sea of Tranquility where Apollo 11 once landed, might actually be a sea, its dark waters reflecting Earth's light back to us with an intensity that would make our nights significantly brighter. The moon's phases would take on entirely new meaning. Instead of simply watching sunlight creep across barren mountains and plains, we'd witness weather patterns emerging from shadow, watch clouds form and dissipate as the lunar day progressed. During a full moon, we might see massive storm systems lit from above, their lightning flickering like distant camera flashes in the night sky. This transformation wouldn't just be beautiful, it would be practical. Ships' navigators throughout history have used the moon's position and phase to find their way across Earth's oceans. But imagine navigating by lunar weather patterns, reading the movement of clouds across that distant world to understand wind patterns that might affect our own climate. The moon's enhanced brightness from its reflective atmosphere and oceans would fundamentally change Earth's nights, making them bright enough to read by, bright enough to cast sharp shadows even when the moon was only half full. But the changes would go deeper than aesthetics. A more massive moon with a substantial atmosphere would alter the delicate gravitational dance between Earth and its satellite. Our tides would be more dramatic, our planet's rotational stability might be affected, and the very climate systems that have shaped human civilization could shift in ways we're only beginning to understand through modern climate change. Research that Earth's seasons might become more extreme or more stable, depending on how this new moon affected our planet's axial tilt. The aurora borealis might appear at different latitudes as the moon's magnetic field interacted with Earth's, creating new patterns of beauty in our skies. And if the view is this breathtaking from Earth, what would it be like to stand on the moon itself? Close your eyes and step with me onto this impossible world. The first thing you'd notice isn't what you see, but what you hear, the gentle whisper of wind moving through lunar valleys, a sound no human has ever experienced on the moon's actual surface. That wind carries scents, perhaps something like rain on stone, or the green smell of growing things adapting to this strange new world. The sky above you wouldn't be the star-filled black that Apollo astronauts described, but something far more familiar, yet utterly alien. During the lunar day, which lasts about 2 weeks, the sky might be a pale blue or perhaps something entirely different. Maybe a violet or orange hue created by atmospheric particles that don't exist on Earth. Clouds would drift overhead, but in the moon's weak gravity, they might tower far higher than any earthbound thunderhead, creating castle-like formations that dwarf anything in our experience. When storms come to this world, they would move with dreamlike slowness. Rain would fall gently, each drop taking longer to complete its journey from cloud to ground. Puddles would form and behave strangely. Surface tension would be different here, and a small splash might send water droplets arcing impossibly high before they slowly settled back down. But perhaps the most breathtaking sight would come during the lunar night, when Earth hangs overhead like a massive blue and white jewel. With an atmosphere to scatter light, you might see auroras dancing across the lunar sky, sheets of green and purple radiance created as Earth's magnetic field interacts with particles from the solar wind. The familiar constellations would still be there, but they'd twinkle now, their light bent and scattered by the moon's breathing envelope of gas, standing in one of the moon's deep craters now, perhaps filled with lakes or even small seas. You might watch weather systems develop around you. The longer lunar day-night cycle would create climate patterns unlike anything on Earth. 2 weeks of continuous sunlight, followed by 2 weeks of darkness, would drive atmospheric circulation in ways that could generate massive storms or periods of absolute calm. And in this strange landscape of longer days, gentler gravity, and alien weather patterns, life would find a way to adapt and thrive. But what kind of life could call the moon home? In this alternate reality, life on the moon wouldn't simply mirror Earth's familiar forms. It would be sculpted by forces that have never shaped terrestrial evolution. The moon's unique environment would become a laboratory for biological innovation unlike anything our planet has produced. Consider plants in 1/6 gravity. Lunar trees might grow impossibly tall and thin, their branches reaching toward Earth like fingers stretched across the sky. Without the constant pull that has shaped every Earth tree throughout evolutionary history, these lunar giants might tower hundreds of feet high, their trunks only as thick as saplings. swaying gently in the moon's slow winds like living skyscrapers. The long lunar day-night cycle would fundamentally alter how life processes energy. Plants might evolve massive storage organs to survive the 2-week nights, or develop the ability to hibernate completely, shutting down all processes during the dark periods only to explode into accelerated growth during the 2 weeks of continuous sunlight. But it's in the realm of animal life where things would become truly extraordinary. Extraterrestrial life on the moon might develop capabilities that seem magical to Earthbound observers. Creatures might evolve to leap enormous distances in the low gravity. Imagine lunar deer that can bound across crater rims in single graceful arcs, or birds that barely need to flap their wings to soar effortlessly through the thinner atmosphere. Bioluminescence might become the norm rather than the exception. During the long lunar nights, creatures might glow with their own light, creating forests and meadows that sparkle like living galaxies. The aurora-lit nights would become stages for elaborate displays of natural illumination as species communicate through patterns of light that would be visible from Earth through telescopes. Intelligence, when it emerged, would be shaped by the moon's unique relationship with Earth. Lunar beings would always see their neighboring world hanging in their sky, never rising, never setting, but always there, cycling through phases that would mark time for lunar civilizations. They would develop astronomy not by looking at distant stars, but by studying the blue and brown and white world that dominates their sky. Perhaps developing mathematics and science through their observations of Earth's weather patterns, its spinning clouds, and its changing seasons. These lunar intelligences might evolve with an intuitive understanding of orbital mechanics that took human scientists centuries to develop. They would grow up seeing Earth's rotation, watching day and night sweep across its surface in real time, understanding from childhood that worlds move through space in predictable patterns. If life truly flourished there, how would it change humanity's place in the universe? The moment we truly confirmed intelligent life on the moon, perhaps through telescopes that revealed structures too regular to be natural, or radio signals too complex to be random, humanity's understanding of itself would shatter and rebuild in ways that would make the Copernican revolution seem like a minor adjustment. Every human religion would face an immediate crisis of interpretation. Are these lunar beings part of God's plan, or evidence that our spiritual understanding needs fundamental revision? Would they have souls? Would they have their own relationship with the divine? The theological implications would spark debates that might rage for generations, potentially splitting existing faiths or giving birth to entirely new ones that could encompass a universe where intelligence emerged on multiple worlds. But the practical implications might prove even more challenging. When NASA missions finally reached this living moon, they wouldn't be landing on sterile regolith. They would be making first contact with an entire biosphere, possibly even with civilizations that have been watching Earth just as intently as we'd been watching them. Imagine the cultural shock on both sides. Humans, who had developed for millennia believing we were alone, suddenly faced with neighbors who had always known we were there. Lunar beings who might have developed their own theories about Earth's life, perhaps even their own version of the Drake equation, calculating the probability of intelligence emerging on the blue world that dominated their sky. The future of humanity would be forced to expand its definition overnight. Would we still think of ourselves as the only intelligence in the local neighborhood? Would our dreams of exploring Mars and the outer planets be put on hold while we struggled to understand and communicate with intelligences that have been 39 times closer than the nearest human city? Trade would become a possibility that would fundamentally alter both economies. The moon's different gravitational environment might allow for manufacturing processes impossible on Earth. Lunar factories could produce materials in ways that Earth-based industry never could, while Earth's greater diversity of elements and more complex ecosystem might offer resources that the moon had never developed. But trade implies the possibility of conflict. Resources that both worlds needed, territorial disputes over orbital space, even competition for energy from the sun could create tensions between worlds that share the same sky. The moon's closer proximity to asteroid belts might give lunar civilizations advantages in space mining, while Earth's larger size and more complex chemistry might make it the intellectual and cultural center of the Earth-Moon system. But this meeting wouldn't just be cultural, it would also reshape the fate of both worlds, living on a moon with atmosphere. And life would create a civilization unlike any in human experience, shaped by forces that would produce societies as alien to us as their biology. The lunar day-night cycle alone, 29 Earth days from sunrise to sunrise, would create social rhythms that barely resemble human patterns. Imagine lunar cities that must plan for 2 weeks of continuous daylight followed by 2 weeks of darkness. Their energy systems, their work patterns, even their sleep cycles would be unlike anything humans have ever developed. Perhaps lunar societies would naturally develop into groups that specialize in day activities and night activities, creating cultures that live in shifts measured not in hours, but in weeks. The constant presence of Earth in their sky would make lunar civilizations the first in our solar system to develop with a deep, intuitive understanding of being part of a binary world system. They would see Earth's weather systems develop in real time, watch storms spiral across the blue world's face, and observe the advance and retreat of polar ice with their own eyes. This might make them naturally more aware of climate change and environmental cycles than humans, who had to develop satellites and global communication networks to achieve similar understanding of our own world. Space colonization between Earth and Moon wouldn't be the one-way journey of exploration and settlement that humans have always imagined for Mars missions. Instead, it would be more like the development of trade routes between neighboring continents. Regular traffic would develop between the worlds, not just governmental missions, but eventually commercial flights, cultural exchanges, and perhaps even tourism. The Moon's lower gravity and thinner atmosphere would make it an ideal launching point for missions to Mars and the outer planets. Spacecraft could be built on the Moon and launched much more easily than from Earth's deep gravitational well. This could create the first true spacefaring civilization, with lunar shipyards producing vessels designed for the deep space missions that Earth-based technology could barely achieve. But the relationship wouldn't be equal. Earth's greater mass, more complex ecosystem, and head start in technological development might make it the dominant partner in the relationship, leading to resentments or independence movements that could play out on an interplanetary scale. Lunar civilizations might develop their own version of colonial independence movements, seeking to establish their sovereignty in a solar system where Earth held most of the economic and political power and beyond society. What about the very forces that keep Earth stable? A moon massive enough to hold atmosphere and support complex life wouldn't just change the sky. It would fundamentally alter the physical forces that have shaped Earth for billions of years. Our oceans, our weather, even the stability of our planet's rotation would all be affected in ways that could range from beneficial to catastrophic to Earth's tides, currently varying by mere feet in most locations, might become massive phenomena that could reshape coastlines twice daily. Imagine tidal ranges of 20, 50, or even 100 feet, creating zones along every coastline where the landscape would be completely different at high and low tide. Coastal cities would be impossible in their current form. Human civilization would have developed entirely different relationships with the sea, perhaps building on stilts or developing amphibious architecture that could function both above and below the extreme high tide marks. But the changes would go far beyond just bigger tides. A more massive moon might affect Earth's axial tilt, which currently wobbles in a regular pattern that helps stabilize our climate. If this wobble were dampened or amplified, it could lead to ice ages or warming periods that would make current climate change concerns seem manageable by comparison. Alternatively, it might stabilize Earth's tilt so completely that our seasons would become more regular and predictable than they've ever been in human experience. The Moon's enhanced gravitational pull might also affect Earth's weather patterns in more subtle ways. Storm systems might develop along different paths, ocean currents could shift, and the jet streams that help distribute heat around our planet might flow in patterns that would create entirely different climate zones than the ones human civilization has adapted to. There's also the question of geological stability. Earth's plates are constantly moving, creating earthquakes and volcanic activity that have shaped our continents. A more massive moon might increase tidal forces within Earth's molten core, potentially leading to more frequent or more powerful seismic activity. Mountain ranges might be higher, valleys deeper, and volcanic activity more common as the Earth's crust responds to stronger gravitational stresses. But perhaps the most dramatic effects would be visible in the sky itself. The enhanced interaction between Earth and Moon's magnetic fields might create aurora displays at latitudes where they've never been seen before. The night sky might regularly bloom with curtains of green and purple light as charged particles from the solar wind interact with our strengthened magnetic field in new ways. Could such a powerful moon ultimately endanger us or save us? Having a living moon would fundamentally alter humanity's trajectory through the cosmos, changing not just our technology and our politics, but our deepest understanding of what it means to be human in an inhabited universe. Space exploration as we know it might never have developed. Why dream of distant Mars when there were living worlds to study just 3 days away by rocket? Our first space missions might have been diplomatic rather than exploratory, carrying ambassadors instead of scientists, translators instead of geologists. The space race between nations might have become a race to establish the best relationships with lunar civilizations rather than a competition to plant flags on lifeless soil. But this could also accelerate our development as a spacefaring species. Having living neighbors who might already have developed advanced space technologies could provide us with knowledge that would take us centuries to develop independently. Lunar civilizations, launching from their world's weaker gravitational field, might have achieved interplanetary travel long before Earth-based technology could manage it. They could become our guides to the outer solar system, sharing knowledge that would make Mars missions, asteroid mining, and even interstellar exploration achievable within human lifetimes rather than across generations. The philosophical implications would be equally profound. Humans have spent centuries debating whether we're alone in the universe, whether intelligence is rare or common, whether our existence has cosmic significance or is merely a statistical accident. Having intelligent neighbors would answer those questions definitively. Life is not rare. Intelligence can emerge under different conditions, and we are part of a larger community of thinking beings. This knowledge might humble us or inspire us. Earth's various nations might finally unite in the face of a larger community that extends beyond our world, or they might compete even more fiercely to establish the best relationships with our lunar neighbors. Human religion and philosophy would be forced to expand their scope to accommodate minds that might think in ways we can barely imagine, shaped by environments and evolutionary pressures completely different from our own. Science itself would be revolutionized. Instead of studying life through the single example of Earth's biosphere, we'd have a completely independent example to compare against. Questions about evolution, consciousness, intelligence, and the fundamental nature of life itself could be answered through comparative study rather than theoretical speculation. And in the end, the greatest question remains: would we share this future or fight for it? Tonight, when you step outside and look up at our familiar moon, hanging silent and silver in the darkness, remember the journey we've taken together through this landscape of possibility. That pale, quiet companion has been humanity's constant witness for every moment of our species' existence, watching over our first steps out of Africa, our development of language and art and science, our gradual understanding that we live on a small world orbiting an ordinary star in a vast universe filled with wonders we're only beginning to glimpse. Our real moon, airless and still, has shaped us in ways we rarely consider. It stabilizes our planet's rotation, creates the tides that may have helped life emerge from ancient seas, and provides the gentle light that has guided travelers and lovers and dreamers for thousands of years. Even without atmosphere or life, it connects us to cosmic rhythms larger than ourselves, reminding us nightly that we're part of something vast and mysterious and beautiful. The moon we've imagined together, breathing, living, inhabited, would have given us a fundamentally different story. We would have grown up as a species knowing we weren't alone, developing our civilizations in conversation with neighbors who shared our sky but not our world. Perhaps we would have been wiser for it, more humble about our place in the universe, more eager to reach beyond our own world to touch minds shaped by different stars. But there's something precious about our actual relationship with the moon's gentle silence. It has left us free to dream, to project our hopes and fears onto its unchanging face, to use it as a symbol for mystery and romance, and the eternal human longing to explore beyond the horizon. Every culture has seen different shapes in its craters, told different stories about its phases, and used its reliable cycle to mark time and meaning. Even now, as you listen to these words, the moon is pulling gently at Earth's oceans, creating tides that connect every shoreline on our planet in a rhythm as old as life itself. Its gravity helps keep our world stable in its orbit. Its phases mark time in ways that connect us to every human who has ever lived beneath the same sky. And perhaps that's enough. Perhaps the moon's greatest gift to humanity isn't the life it might have held, but the dreams it has inspired, the questions it has raised, and the reminder it provides each clear night that we live in a universe vast enough to hold wonders we haven't yet imagined. Oh, sleep well, knowing that our silent neighbor continues its ancient watch, unchanged and unchanging, a reminder that some mysteries are meant to endure, and that sometimes the most profound connections are made not through words or signals across space, but through the simple act of sharing the same sky, the same light, and the same sense of wonder at being alive in a cosmos full of infinite possibility.